So we're filling in the sequence and series, it's just sequences for now, sorry, arithmetic and geometric, and we have 6 examples here, and we have to put them in the correct spot in the table and then fill out the rest. So I am here, this third one here, 2, 6, 18, 54 is being multiplied by 3, and the first term, the line leader, is 2. I guess I forgot to put the first term for this one here, -8. Okay, let's go down here. -5, 10, -20, 40. Is that being multiplied by the same number, or are you adding the same number each time? Multiplying. So it's going to go down here as a geometric. So geometric is multiply. Arithmetic is add. Okay, guess what? Surprise. It could be add or subtract, and this could actually be multiply or divide. But we don't have a division example here. So -5, 10, -20. And for this one, what are we multiplying by each time? How is it switching from negative to positive, negative, positive? So we're multiplying by -2, and the first term was -5. Okay. 31, 27, 23, 19, 15. We're subtracting, so it's going to go, is it arithmetic or geometric? Arithmetic. I know you want to say arithmetic, but oops, I made a little typo. There you go. And what's our common difference? How is it? It's decreasing by 4? Okay, -4 in the first term was 31. So 100, 1,000, 10,000 is geometric. And what are we multiplying by each time? 10, and the first term was 100. All right, here we are. So now we're going to do, there's recursive formulas, which means, are you ready for this definition? You ready? Recursive means we use the previous term. We're going to use the previous term to get the new term. Explicit means you can just plug in. That's the difference. I'll explain. So for this top table, we're going to use arithmetic, and we're going to use the recursive formula first. So the recursive formula says to get any term, you use the previous term and just add the common difference. So this is the formula here. We're going to use this formula first for this column here. So a sub n equals a sub n minus 1. We don't know what those are. We just leave them like that. But then we do know what d is. And what's d? Plus 1, yes? D is the common difference, and the common difference comes from this table. So we write plus 1. So that's it for this column. So I'm thinking you don't know what's going on, but you're just copying this down. So maybe we'll explain in a minute. Let's just get the formulas down. Okay, explicit formula. An explicit formula, where are we? We're explicit formula. Arithmetic is here. A sub n. A sub n stands for the term you want to find. So a sub n equals a sub 1. What does a sub 1 mean? The first term. So the first term in our example here is 0, plus the common difference, d, is 1, and then n minus 1, you leave n minus 1. Okay? Let's do another example. A sub n equals the first term. So the first term here is -8 plus 6 times n minus 1. This should remind you of y equals mx plus b. So m is your slope, your common difference, times x, and then plus b. B is the y-intercept. B is your initial value, so that is the first number here. Okay, how would we write this one? A sub n equals, all right, what goes first? 31, the first term. And then instead of plus, we're going to put minus 4 times n minus 1. Okay, anytime it asks you on a test to find like the 15th term or the 40th term, you can always, especially if you have a calculator, can't you just count up to that term if you want to? Yeah, actually this one we can do in our head, right? Oh, it's a little confusing because the first term is 0 and we want the 15th term. This means a sub 15, okay? So if the first term is 0, what would the 15th term be? Would it be 14, 15, or 16? I agree. What's the 40th term going to be? Okay. Do you see how we didn't have to use a formula for that one? So you could figure this out without the formula. Okay, this one, to get to the 15th term, you can either add 6 and keep going until you get to 15 terms and just keep adding 6, or you can plug in 15 into the explicit formula. Do you see, did you write plug in? Do you see that? So if we want the 15th term, then you can take -8 plus 6. N stands for 15. So if this says n minus 1, what's going to go here? 14. And these boxes are way too small, right? All right. -8 plus 6, 14 times. The answer there, find a place to put it, is -20. Oh, Katie. It's not -24. My peeps. Sorry, this is a video. Don't look. Don't look. Where's my whiteout? Everybody makes mistakes. Okay, it's actually, it should be -25. Is that correct? Or did you get something different? Just kidding. I have a typo. Positive or negative? Positive 76. There's no way it should be a negative number. I am confused. I know what happened. On my answer key, they put this one up here and this one up here in a different order. Are we recording? All right, move on. 76, I agree. What about a sub 40? A sub 40 will be -8, but then you need to add 6, not 40 times, because -8 counts as the first number. So we're going to add it 39 more times. So in your calculator, if you want, -8 plus 6 times 39, 226. All right, ready? Let's do this a little faster. 15th term. What do? You take the first term. What's the first term? 31. And we want to subtract 4 14 times, 1 less than that number, because that would get you to the 15th term, because 31 is the first term. And that answer is -25. That's what I wrote before. Okay, how do you get to the 40th term? You start with the first number and then you subtract 4 39 times. And that's how you get to the 40th term. And that's going to be -125. How are we doing? Okay, do you guys see the resemblance in a linear function here? So a linear equation like an x and y graphing a line is called an arithmetic sequence. Yay, math. Are you ready for geometric? Hang in there, yes? We okay? Okay. Let's get some formulas down. So the recursive formula for a geometric sequence is A equals R times the previous term, and the explicit formula is the first term times r to the power of n minus 1. All right, here we go. What's the common ratio for the first one? 3 times a sub n minus 1. And the common ratio for the second one is -2 times a sub n minus 1, and so on. You guys, all this means is to get the next term, you multiply by the common ratio. So you're going to have questions where it says, what's the next term? Oh, I just multiply by 3 to get the next term. Okay, the explicit formula, you use the first term, a sub 1, times the common ratio to the power of n minus 1. This should look familiar from our exponential unit. The first term times the common ratio to the n minus 1. And I'm going quickly because I believe in you. I know you can do it. Time to work hard. And we're running out of time. Okay, now we're going to use the explicit formulas to find f of 15 and f of 40. Are you ready? Are you here? Are you with me? So what's 15 minus 1? 14. So we're going to have 2 times 3 to the power of 14. These are going to be really big numbers because remember you're multiplying, and if you're ever dividing, then they'll be really small numbers. Okay, so 2 times 3, oh my gosh, this is really big, to the power of 14. Okay, what do we have here? 9,565,938. I can't fit it here. All right, this is going to be 2 times 3 to the 39. Oh my gosh, that's going to be so big. If only there was a way to write really big numbers, like a shortcut way. What? There is? What's that called? Scientific notation, actually using it, 8.105 times 10 to the 18. Am I copying down the right answers from my answer key? You guys, there's another secret. I have an answer key right next to me. Okay, next one. This number, and we're running out of time. Have a great day. I'm going to do a minute and a half more on this video. Hold on. Okay, we're back and let's finish this up. So to find the 40th term here, ready? The first term times the common ratio, and then you subtract 1. And the reason we're subtracting 1 is because the -5 counts as the first term. So we only need to multiply it, 39 times. And right now you're going in your calculator, you're going, do, and you're typing this in, and we're getting really big numbers. And I don't have it in scientific notation, I just have it really big. So ready? 2748779069440. Crazy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2.7 times 10 to the 12. That's what I counted. Ready? This one, what's it going to be? The first term times the common ratio to the power of 14, and 1 times 10 to the 16, and the first times 10 to the 39, and we get 1 times 10 to the 41. So that's a little introduction to sequences. I keep saying series because that means you just add up the patterns, but we have arithmetic and geometric sequence. This should really remind you of lines and of exponential functions, and you can always find the next term by adding or subtracting or multiplying or dividing. All right, best of luck. Thanks for watching.